Hello, I'm Professor Stephen Kelty. My area of focus is in the research involving a wide variety of materials, many of which are used in solid oxide fuel cells or solar energy conversion materials or chemical sensors. Recently, we've been interested in metal oxides that exhibit a wide variety of properties that are related to these materials. You might be familiar with certain metal oxides such as aluminum oxide or iron oxide or titanium oxide. Some of the more exotic materials, oxides, metal oxides, that exhibit some of the properties that we really are interested in include hafnium oxide, niobium oxide, and zirconium oxide. In many cases, the introduction of guest or dopant atoms into these otherwise perfect crystals is what leads to the properties that we're of most interested in. Our interest in these technologies is in discovering the details of how these guest or dopant atoms behave in the crystal, which leads to a better understanding of how they actually work. So we investigate these materials using a wide variety of computational methods that provide a much better understanding of what these materials how they might actually behave, well beyond, in many cases, what experimental methods might be able to reveal. Rather than thinking of computational methods as replacing experimental methods, we view them as complementary tools, and we often collaborate with experimental scientists elsewhere in the building or elsewhere around the country or around the world. The experience that student researchers gain while working in our group include, obviously, a better understanding of how these materials actually work, but at least as important is how to properly use computational methods for solving these problems. So if you're interested in helping us with some of our current research projects, I'd love to talk to you, or you can find out more on my webpage, which is linked to the Seton Hall webpage.